go garbage in, garbage out. If you put in bad information, you get out bad information. So everything that people do in scientific and technological research has to be validated. If you do numerical analysis, if you use economic, one of my questions, often people use Markov or use some, so they have all kinds of nice results. They say, how do you know that these results make any sense? Okay, maybe you made a mistake, you fell asleep on the keyboard and you put in some wrong number, or maybe the assumptions in the program, the commercial programs, were wrong assumptions. So we always, most good journals will require validation. If you did experiments, you say, I measure the temperature with thermocouples and the temperature difference is 0.1 degrees Celsius. Okay, so you say, how do you know it's 0.1? So the thermometer reads, it's manufacturer's specifications. That's nonsense. You have to calibrate the instrumentation, and most good journals expect that you show that how it was calibrated and how you really know that the numbers that you have flow or anything, concentration. How do you know that this? What is the plus minus percent error? So there's formal error analysis. Good subject. I'm sure you teach it to the students. How to do experimental error analysis. That's very, very important. So in modeling, the modeling error means your assumptions that you made, could be in error. Solution convergence, if you're doing computation, how well does it converge? Grid dependence is very important. You calculate for different grid sizes and see if you change the grid size, does it change the results or not. And then at the end, in most of our work, we should check the overall system if it still satisfies conservation laws. Let's say that you do fluid mechanics problem, so the mass conservation has to be done. Although it is in the equations, in your calculations, mistakes may have come in. So at the end, after you finish, you calculate all the inputs, all the outputs, and they must be within a certain percent to say that you're satisfying mass conservation, energy conservation, species conservation, and so on. So this is expected that those are checked. Input data errors. Often we don't have exact input values, so they have to be estimated in that, and so on. There may be other sources. So in experimental work, as I said, description. Thanks so much. The description of the measuring instrumentation, and not only that, how did you install the instrument? My experience is mostly in thermal sciences, and so if I put the thermometer in this pipe, this is a pipe, this is a thermometer. If I put it here, it will be one value. If I put it here, it will be another value. If I put it here, it will be another value. And it's not the same value. Okay, so you should explain how you put it in, where you put it, and why you think it is the best position to measure. As an example, so how was the instrumentation? Very often we get papers saying, well, we measure temperature. Nobody knows how and where. If you have a duct with the airflow, you have a big gradient across, so where was it really measured? And why do you think that this position is relevant? Calibration, individual measurements, and the result. So the combined error. For example, you calculate force. Force is equal to MA, okay, mass times acceleration. You may have an error in measuring mass, an error in measuring acceleration. The combined error is you have to sum up the errors, that's the error in the force. Now this is a simple example, but often there are many parameters, so you have to combine all of them and see what is the estimate of the error in the sometimes statistical aspects, if values are changing with time, and so you have to include that. Okay, and it is very impressive for the reviewers and the editors if you really subsection, error analysis, then they know that the researcher was serious about their work, not just trying to publish something that the students did. Just very serious. So say error, and this is how I measured, this is my error, and it's not only for the reviewer and the editor, but the researcher himself gets more confident that what he is presenting is closer to the truth. So, and validation of various types and so on. So this is really, as I said, it's painful because it takes time. And often you find that what you measured is wrong. Because when you do the error analysis, you find errors that are much bigger than, let's say you predict that the efficiency is increased 10%. And the errors are 50%. Okay, so what does it mean? You know, it could be anywhere. Use of illustrations. You say one picture is worth 1,000 words or 10,000 words. It was a very good illustration. Nice graph.